So to start off, how many of you were here for the Parador talk last time? Show me a rate of hand. Okay, a few. How many of you have played with Ingress before? Great, awesome. Our legacy game. So these are two of Niantic games, and they are legend, legendary. Yes, yes, it's called Legend. Yeah. So these two are actually very different game characters, game loops, and different vibes too, attract different players. But what do these two have in common? Take a look. Right, I hear maps. That's right. It's base maps. So base map is the digital representation of the real world. And as you can see on the screen, it shows the representation of the road, the land use, the parks, and the water features. And here at Niantic, our mission is to encourage people to go outside, to play, to social, interact with each other. And maps is at the core of all these missions, and it's the connecting tissues for all of it. And Lightship, we take maps to core, and with Lightship Maps, we take the technology that powers our location-based games and then package them together and make it available to you all, developers. So what is Lightship Maps? Lightship Maps is easy to use, customizable real-world maps optimized for building location-based AR experiences. With this, developers have access to the technology we use to power our most popular location-based games. And it's available in both Unity and Web AR. And I know for some folks here stay for the AceWall talks and knowing all the amazing things that you can do with Web AR through AceWall. We're also excited to share with you that the Lightship Maps is also available on AceWall. It was available since last year, actually, and you can check out how you can build a web-based experience using AceWall tools and start getting started by scanning this QR code and lead you to the sample example and to get started. For today's talk, I'm going to focus on Unity Maps. For Unity, it's a product we just launched last week to public. It's currently in public beta. So with Lightship Maps, we took developer-centric approach. That means that as we're thinking with the thinking as well as building, we took developers' need to heart. So we talked to many developers, understand their needs, understand their pain points of building experience with maps, and we took all their feedbacks, and as we're launching this product, we're really honing in, focusing on 4 core pillars to deliver the value to maps to developers, to make sure they have a good experience. So pillar number 1, Lightship Maps giving developers the power to customize the look and feel of the map. Developers have full control over the visual aesthetics of their maps. Right out of the box, developers have access to 19 pre-configured map themes as illustrated here. And then developer can also, that's pre-configured theme is to get you started quickly. But developers also have the toolkits to full customize it to making sure the visual aspects fully align with the brand image, the story they're trying to tell, and the game experience. Pillar number 2, Lightship Map provides the toolkit to create immersive experiences grounded in location. With Lightship Map, developers have access to the underlying data with the geometry, the semantics of the geographic feature, and with this data, developer can create their interactive experiences based on physics and create a more natural interactive experience for their users engaging with the surroundings. And also, with that, it creates a profound sense of realism. And on top of that, developers can also procedurally generate content based on maps, based on the data attributes of the map data itself. For example, a developer can walk by the parks and they can create the wood objects based on because they're part of the parks, and then like fish spawning out of the water as they walk by a riverbank. And all these will be shown to you in the sample project example that Mara is going to walk you through later part of this talk. Pillar number 3, Lightship Maps is a one-stop shop for creating location-based AR experiences. So as part of this Lightship platform, with developer using one API key, developer will have access to the full suite of SDKs to create this end-to-end location-based AR experiences. As you can see on the GIF on the right side, developers can first use the maps to see where VPS activate locations are near them, and then knowing the distance between them, and then moving on to identify VPS active waste spots, and then continue on with the VPS activation localization experience as illustrated this example. And also the map SDK is independent of ARDK. It works well on its own, and it's also compatible with ARDK to give you the full convenience and flexibility. So pillar number 4, after talking to developers, we know that making it convenient and easy to use is something very important to developers. But on top of that, performance is also an aspect we pay a lot of attention to. So with Unity, we optimize the performance map building experience by leveraging Unity job system, as well as the caching system, so that developer can iterate with map experience a lot faster. And then the map tiles are also cached on the user and user's device, so that for a lot of AR experiences, as they switch from the map view, checking out where things are around them, to camera view to start an AR experiences, they do not have to download the maps each time. So it ensures a more smooth transition and experiences in areas with lower connectivity. Great. So I just shared with you what developers can do with Lightship Maps. But then some of you may hear, hey, I'm developers. I'm curious about how Lightship works. So buckle up. We're about to zoom into the Lightship Maps. Do a quick show of hand. How many of you have experience building with map products before? Wow, a lot of them. Great. Okay, awesome. So some of you who are relatively newer to this building with maps wanted to quickly walk through some of the map concepts that will help you as we guide you through the Unity part later. So first is the map layer concept. So in Lightship Maps, the real world is represented by layers of map data, as you can see here. So the layers, you can see the layer, imagine the layer as a layer of land use. I'll show you where the parks are, a layer of road with geometry, the shape, and then water with the area and the lines of showing the boundaries. These layers are aligned vertically and also stacked and stored in a vectorized map tile format. So Lightship Maps is vector maps, so vectorized tile format. So with vectorized, so each layers is represented by points, polylines, polygons, instead of individual pixels based off the satellite images. The key advantage of the vectorized map tile is that it's a lot smaller. So that means translating to experience, it's a lot smaller for fast loading, as well as smaller usage for the bandwidth. Bring that together. You can also develop and build your own content on top of these map layers, bring your own data, build your content experience and objects on top of that using the same structure in the Unity builder. Great. So now with this, I share with you what you can do with the maps and how the basic map concept work. Now I'm going to transition to the second half of this talk, where Brent is going to come up stage to talk to you about the architecture of the maps, as well as show you how simple and easy it is to get started in Unity. And then followed by Mar, who is going to walk you through examples of how you can build these resource games in a with few line of code in the packages we provide. So for the developers out here in the crowd, in the audience today, the talk is going to get more exciting. Now, give it up to Brent.
All right, awesome. Thanks so much, Helena. As she mentioned earlier, I'm Brent. I'm a senior partner engineer here at Niantic, and I have had the absolute pleasure of working with Mar and the other Lightship Maps developers on this awesome product for about 6 months now. So I'm pretty invested, and I'm pretty excited to show you a little bit of a deeper dive into this product. So as Helena mentioned several times, Lightship Maps is all about data. So that's the real-world data that we have in a vectorized format. And what I want to show you today is how that data gets from us at Niantic to you as individual Unity developers, and then to your users. So it all starts in the Niantic tile store, and that's where we store that vectorized map tile data. It's encoded, and it's in a much smaller size. And we have the Lightship Maps core library, and that's the underlying API for accessing all of the real-world data in the Niantic tile store. But the way that we make it easy for you to access that data in the first place is with our Lightship Maps SDK for Unity. So the SDK, as you might imagine, is a curated set of tools, scripts, and resources that make it really easy to communicate with the core library and get the data that you're looking for very quickly. So let's dig into the SDK a little bit, and for that, we're going to go into Unity. Cool. So this is a pretty much brand new project in Unity, just made it in Unity Hub 2021.3 LTS using the mobile core URP template. Takes like 5 minutes to do. And I've also already installed the Lightship Maps SDK package and set up my API key. That also only takes a couple minutes. So, but once you have those prereqs set up, it's literally 3 simple clicks to go from nothing in your scene to having a functional Lightship map. So I'll show you that right now. There's this nice happy Lightship button up here. 1, 2, 3. And so I kind of add a few things, did a couple things. But before we dive into what those things are, let's just see what happens when we hit play from that empty scene. And there we go. We have the real-world map tile data streamed in and decoded and rendered into this mesh map. The game view doesn't really look like anything because, again, this was a totally empty scene. I didn't even move the camera. But that's how fast you can get from 0 to having a functional Lightship map in Unity. So let's dig in a little deeper and see what this mysterious Lightship map prefab is all about. So the Lightship map prefab consists of 2 main components. It's the Lightship map manager, and that's kind of the brains of the operation. It's what communicates with that underlying core library and requests the data based on the user's position and a given radius. And then we have the Lightship map view, and that's, as you might imagine, responsible for everything that you see on the Lightship map, from the color palette to the meshes that are actually being rendered. It handles the communication with all of those things. And the main center point of that, the thing that's really doing a lot of work here, is something that you might otherwise not think is doing a whole lot, is this map theme, which sounds like it might just consist of a color palette, but this is doing a lot of heavy lifting. So this map theme consists of a bunch of feature builders. As Helena mentioned earlier, the map data consists of a bunch of different layers, things like land use, roads, bodies of water, etc. And in the Maps SDK, we've included a bunch of mesh feature builders that build based on that data. So let's take a look at this map theme. I'll just give you a super quick overview. It's basically just a list of these different builders. As you can see, for buildings, highways, transit, sand, etc. There's also some additional settings for skyboxes, and this is really to get the map to look and work the way that you want it to. But what if you don't want that default light unlit theme that we have here. Well, as Helena also mentioned before, we have included 19 pre-configured themes in this package, and a bunch of them are like, I don't know, I think they're really cool looking. So there's some that just have different color palettes, and there's some that have totally different functionalities, including rendering buildings certain ways, or not rendering other features, or rendering features that the other ones don't render. And I'll also show you in a minute how you can configure these builders and these themes to kind of modify and add the behavior that you'd like to see. So one of my favorite themes is this arcade one. I look like there's a lot going on here with all of these different 4 themes. Really, there's kind of 2 main things going on. These lit themes are for 3D scenes, and these unlit themes are for more 2D top-down scenes. It's kind of whatever your use case is, we kind of have a theme for you. And then by default, the Lightship Maps SDK uses URP-based themes and materials. But as I'm about to show you, it's really easy to swap out a theme. So if your project is non-URP, it's not a problem at all. All right. So we're back in this Lightship map view, looking at this map theme here. And let's just drag in this arcade unlit theme URP. And hit play. And as you can see, it's just a totally different color palette. All of the materials on all the different builders have been changed, and yeah, we've got 19 different ones. I recommend you check them out whenever you look at the SDK. There's some really cool ones in there. But since this scene was bare bones, let's actually take a look at a scene that has a little bit more functionality. And for that in the Maps SDK, we've included some sample scenes, including, no, thank you, Unity, including a top-down view that lets you scroll and pan around just so you can see the basic behavior of the map. So as you can see, I can pan around, and you can see in the scene view on the left there that the map tiles are basically getting reused and recycled. That's, again, for performance reasons, to not use too many resources at once. And keep a close eye here as I zoom out and see what happens. There's a little bit of a flicker, as you see as I zoom out. But that flicker comes from the latency between downloading the map tiles and them getting rendered. But now that they've been downloaded once, as Helena said before, they've been cached. They're already on the machine or on your user's device. So now when you zoom out, it's like barely noticeable. Super nice. Okay. And the last thing I want to show you is how we can actually change the builders that are on the themes a little bit. So what I'm going to do is I'm going to drag in this theme over here. This is just the same theme you saw originally. And if you want to modify the builders on the themes, 2 ways to do it. You can go the long way and click all these game objects and go in there. But we've also made it really easy by having this sort of like nested editor in here, so you can just kind of scroll and look in one place. You can look at all the builders here. So the first thing I'm going to do is, instead of rendering all of the buildings like you saw before, let's just say I want to render only residential buildings. So let's hit play and see what's different. And hopefully you're able to notice, this is the Seattle area, by the way. Hopefully you're able to notice there are fewer buildings being rendered. Seattle has a huge mix of residential, commercial, industrial, a lot of different types of buildings. But here you're only seeing the vast number of apartments that are in the downtown Seattle area and none of the other buildings. So the map layers and the different features give you a lot of ability to customize what data you're using to make things show up on the map. And at the end of the day, you can customize these builders in any way you want. Really what we're giving you is access to the underlying geographic data, and you can use that for a bunch of different things. And Mar's actually going to show you a little bit more about that in just a few minutes. Cool. All right. Let me skip through this a little bit. All right. So again, as Helena mentioned earlier, we're trying to hit the nail on the head with performance. We like to say that performance is one of our features. So in order to do that, we're leveraging the Unity job system and the burst compiler to really squeeze out every last frame and every last CPU cycle on yours and your users' devices. But if you know Unity and you know the Unity job system, it's a little complicated to work with. It's doing weird multi-threading stuff. So if you're just getting started or you want to prototype, we've actually included what we call standard builders as well. And they do the same things that the performance ones do, but they're a lot easier to implement. So really, really good for prototyping. And then once you're getting into a later stage of production, you can convert those into performance using the Unity job system. And again, give your users a really smooth experience. And all of these builder types, both the ones I've mentioned and the ones Mara's going to show you in a little bit, can all be customized, inherited from, re-implemented if desired. At the end of the day, this SDK is a set of tools, but you can add your own tools to the mix. You can customize this in any way you'd like. So one last thing I want to mention before moving on is, in addition to using real-world geodata to place objects in your application, we also give you the ability to sort of like arbitrarily place game objects. So you can place an object at a specific geographic location at a latitude and longitude, and that game object is going to persist in the map at that location the whole time. So if you, Mara's going to show you a really cool example of that in a few minutes. But if you want to place an object at a specific latitude and longitude, and then you move away and then you get back to it, that object's going to stay there, and it doesn't have to rely necessarily on the underlying geodata. All right, so without further ado, I'll hand it off to Mara to show you maps in action. Thank you.
Hey everyone, I'm Mar. Thanks Brent, thanks Helena so much. I'm a developer, support engineer, and one of the folks helping out with the Lightship Maps SDK. I'm really excited to have a chance to go through and show you maps in action. As Helena mentioned earlier, we really were thinking a lot about how do we make this a frictionless experience for our developers. And so my goal with what I'm going to show you next is how easy it is to do practical, simple things using the Maps SDK. The first thing we're going to do is go through, as Helena mentioned, our game resource sample, which is included as part of the Maps SDK. And then after that, we'll do kind of like a high-level overview of how to integrate our VPS coverage API, which is included as part of the ARDK alongside the Maps SDK. So yeah, let's go ahead. Let's get started. All right. So yeah, maps in action. So we've got a simple resource game. It's included as part of the Maps SDK. The thing that we really want to highlight with this game, and I'm hoping that you'll take away, is how easy it is to place custom objects or your objects on the map using both our built-in underlying map data as well as being able to use our map layer system. So with that, I'm going to go ahead and switch into Unity if I scroll the right way. Okay. All right, so here we've got our game sample. I already have it spun up using the same process and flow that Brent showed you earlier. Again, this is included as part of our Maps SDK package. So I'll go ahead and press play to kind of just show you how it works. So this is a resource game. We've got our cute little Dodie. Just at first glance, you'll see that there are some trees that are spawned all over the map. And that's actually using our custom feature builder. We've got an area object builder. I'll jump into the code just a little bit in a few minutes, but what's really cool is this is actually a custom builder that's using some game logic that we spun up here. So you're gonna go and collect some wood, and then we're gonna, go ahead and just build a structure. And that structure is actually using a completely different system. So that structure is placed using our map layer system. And so let me go ahead and jump back and we can jump into this a little bit more. All right. So firstly, with the map feature prefab spawner, again, that is a custom script that is inheriting from the area object builder. And what that's doing is it's taking advantage of the underlying map data. So what you saw in the game, if I jump back, with these trees, we've got our trees spawning only in parks. So if we go to our Lightship map, as Brent showed you earlier, this is included as part of the map theme. And so we've got our custom builders here where you specify your prefab. We have some other properties that you can customize and configure. It's super easy to use, which of course was the idea. We specified the map layer, in this case, was land use, so that way we can spawn just in parks. If I were to stop this and then clear this out, and then like let's say we want to do water instead, and go ahead and press play, and remember we're doing this live and hopefully it works, and we're just going to go with it. Now you can see that, how cool. We've got trees spawned in water, which makes a lot of sense. All right, so it's really that easy. We did this in like 2 seconds, but I'm sure you could see how powerful that is to be able to take advantage of that underlying data. And then to kind of jump back to the layering system. So with the map layer system, what that is, it's basically a mask that overlays on top of the entire map. And that's really powerful because what we're doing is we're doing all the heavy lifting to make sure that as the map is moving, as your user is moving, we're making sure that their position is persisting on the map. We're doing all the heavy lifting. It's built into the SDK, and you're able to do that with just one line of code. The setup for it is really, really simple. If we go back into Unity really fast, I can show you what that's looking like. If you see here, we've got a child of the Lightship map, which is this building layer, which has a map layer component on it. And then in the example, if you remember, we had the sawmill. And just by having this layer game object placement in there, it doesn't have to be childed to the Lightship map, it just has to be somewhere in the hierarchy, somewhere in your scene. That's all you need to do to be able to leverage the power of this map layer system. So it's super easy to use. You can get something going. And again, this is included as part of the Maps SDK, definitely something after this download, wink, wink, check it out. And yeah, so next, now that we've had a chance to show you how easy it is to place objects on the map, I'm going to give a really high-level overview of how you can leverage the BPS coverage API alongside the Maps SDK, mostly because actually right after this talk, shameless plug for Braxton, he's going to do a talk where he's going to go and do a deep dive into this. So I'm just going to kind of talk through like how you can do this really quick and dirty. So if you take a look here, what you see is on the right-hand side, our map with a button that loads up some markers and some visual cues that your user can use to know what they're looking for when they are looking for a way spot to localize. What is actually happening under the covers here is we've got our Maps SDK, of course, providing the map alongside the map layer system, the polygon renderer and the line renderer, which is actually drawing those markers on the map. And then we're getting the data from the BPS coverage API. So taking a quick glance at the code, it's actually super simple to get that going. For requesting the coverage areas, it's really just one line of code. And then for drawing it on the map, that's just 2 lines of code. That's it. It's really, really easy to get this going. We actually have a really good integration guide on our documentation site. If you guys want to check it out, it's there. And yeah, so that's pretty much it. Those are some of the more common use cases that our developers were asking for. And with that, I'm really excited to show you some of the really cool experiences that our developers have been building with Lightship Maps.